In this video, I'm going to show how to do a design optimization with Maxflow.app. The example is taken from a benchmark paper. I want to optimize the cross-section of a cantilever beam for minimum weight while satisfying stress and deflection criteria. I'll go ahead and take a screenshot and then paste it into the workflow for easy reference. Now, let me start by making the workflow for the calculation. In this case, the calculation is just a formula, so I'll use the Python component. I'll make it look like a real workflow by breaking it into 3 components. One will be for calculating the volume, another for calculating deformation and stress, and another one just for feeding in the inputs. These will be connected together to make the subflow. Now, I'll set up the design of experiment with the DOE run component. I'll do this by dropping the subflow on the DOE loop. The subflow is now hidden, but I can double-click it to bring it back if desired. The DOE component automatically knows the inputs and outputs of the subflow, so I'll just need to enter the ranges for the parameters, and I'll tell it how many points I want to probe the design space. In this case, 5 points along each parameter. And here's the most important component for finding the optimal design with confidence. It takes parameters and responds we have just created. That's it. Let's run the entire workflow. It takes just a couple seconds. Now that it's completed, let me open up the DOE viewer by double-clicking on it. Now I can see how the outputs change in real time, both quantitatively and visually. I can also see how the Pareto front representing the trade-offs between outputs, as well as other options. But let's focus on optimization. In this tab, we can easily specify the design criteria, which is to minimize volume while keeping stress below 5,000 and deflection below 0.1. Click this Find button. This surrogate-based optimization runs really quickly, usually within about 10 seconds. And here we are, the optimization result. Keep in mind that this is a global optimum. The algorithm searches the whole design space for it. And that's it. Pretty powerful and practical.